Okay, we've seen the basics of integration. We got the basic rules down. If you hand me the handful of functions that I know how to integrate, I can integrate those. We're now learning our first big trick. This first big trick is called integration by substitution. Substitution. This is often called a U substitution. In more advanced calculus classes, there are other things called substitutions that are kind of variations on this trick. This is the only substitution we're using. On the homework problems, I think I called it U substitution. And this fundamentally works as being like the chain rule backwards. I forgot to turn my music back on. So let's begin by thinking about a chain rule problem. Let's say I wanted to take the derivative of e to the cosine x. This is like the standard example of a thing that I would want to use the chain rule on, right? The outside thing is e to the, what's the derivative of e to the something? It's e to the, leave the inside alone, times the derivative of the inside is negative sine x. There you go. So the derivative of e to the cosine x is e to the cosine x times negative sine x. Well, that tells me that I know, let's see if I move the negative to the other side to make it more natural. That tells me that I know the integral of e to the cosine x times sine x. Because I know it's the derivative of this, the answer must be negative e to the cosine x plus a constant. How do we do that? This time we did it by just happening to start with the answer and take the derivative. If I didn't have that line written down there, what would we be doing? Can we break this up into steps? Substitution is the technique that lets you do this in a more organized way. Let's take this problem and do it in slow motion in substitution to see how this would happen. If I was handed the integral of e to the cosine x times sine x dx, how would I do a substitution? Well, step 1, I guess step 0. You sure you need a substitution? Double check this isn't one of the 5 functions that you know how to integrate. If you know how to integrate it without a substitution, just do that. This is worth thinking about in all these problems, is double check that this big fancy tool you're using is being used on a problem that actually needs a big fancy tool. I know how to do the integral of e to the x, or of sine x, or of cosine x, but two things multiplied together, I don't know how to deal with. Cosine inside of e to the, neither of these is something that shows up in the integral formulas that I have, the basic ones. So I need some trick. We're going to try a substitution. Step 1, pick an expression to be a u. We want u to be something. We get to choose the u. The u is our pick when we do this integral. A good u choice is something that shows up inside a function and a great u choice has its derivative outside somewhere. So in this case, I'm going to pick u to be cosine x. The cosine x shows up here inside the e to the. What's the derivative of cosine x? The derivative of cosine x is negative sine x. Well, I don't have a negative sign there. I don't have a negative sine x there, but the negative is kind of not of a big deal. You don't need to get something exactly right. Getting something close is good enough, and off by a constant is definitely close enough. Being off by a multiple of a constant is definitely the thing we want. I wrote what du is too fast. Step 2 is find du. the thing you're thinking about is du dx equals stuff. Du dx is not a fraction. You're not allowed to multiply both sides by dx, but do it anyway. This is a place where we pretend it's a fraction because the mnemonic device works out correctly to deal with the chain rule the way we want it to be. Du is going to be some multiple of dx. Or, you don't have to find du dx. Maybe you have x equals some stuff, and you can write dx du equals the derivative of that. So dx is that stuff times du. There's two options here. Either I have a formula for u or I have a formula for x. Either one works. Sometimes you can have x stuff and u stuff on both sides. There's kind of a lot of ways at this, but mostly it boils down to taking a derivative of something. Here I have a formula for u. U is cosine x. The thing I think but don't write is that du dx is negative sine x. The thing I do write is that du equals negative sine x dx. I told you before that dx is kind of like a closed parenthesis, but it's a closed parenthesis that you're multiplying by. Here's where that multiplication really matters. So step 1 was pick our u. Step 2 is compute our du. Step 1 is a thing we make a choice about. Step 2, we don't have a choice. We're taking a derivative, and the answer to that derivative is our answer. Step 3 is now convert the integral into u's. Using the formulas that you have before. Your u equals this, du equals that. Or using x equals this, dx equals that. Whichever way you have it written down. Use those until it's only u's going on. There are some teachers... Oh, let's try this out. How does this work? The original integral was e to the cosine x times sine x dx. We need to write down something that is exactly e to the cosine x sine x dx using these rules to translate our x's into u's. For example, this cosine x can now become a u. I'm going to do this slowly in several steps. Integral of e to the u times sine x dx. Some teachers would flip out at this line. It doesn't actually make sense to have a formula with x's and u's mixed up. If you have x's and u's mixed up, you're not done. I think it's fine to write this down. The key thing is you're not allowed to integrate yet. If there's any letter x left in your formula, you're not allowed to actually do the integral. Part of this conversion is our dx is going to end up being converted into a du. How can I do that? One thing you could do is just solve for dx is du over negative sine x. I can now plug that into here, and that'll get me somewhere. I get integral of e to the u times sine x times du over negative sine x. And now these cancel, and I get integral of e to the u times negative du. And now it's only u's, no x's. That works. Most of the time, though, I don't need to have this whole sine x canceling thing. It's better to notice that, let's copy this stuff. There's sort of a slicker way of doing this, which is to notice that, I have du is negative sine x dx. I have almost negative sine x dx. I'm only off by the minus sign. I can fix that if I write a minus sign inside and a minus sign outside. They would cancel each other. So I haven't changed the integral. My goal is to write down the same original integral. But now I'm able to just use this formula for du and do it all without the solving for dx thing. I'm ending up with the same thing. The minus sign's in a different place, but that's fine. Either way you get, sometimes you need to do the weird way, sometimes you don't.